Good day, class. Today I'm going to give you a brief discussion about the Fibonacci sequence. So here we can see the Fibonacci sequence is the series of numbers. So we have here 1, 1, 2, 3, 5, 8, 13, 21, 34. Wherein the next number is found by adding up the two numbers before it. So we are getting this series of number by adding up the two numbers before it. For example, here we have here the 2, this one is found by adding the two numbers before it, which is 1 and 1. So we have 1 plus 1 is 2. This is where we get the number 2. Then the 3 is found, this 3 is found by adding the two numbers before it as well. So the two numbers before it are 2 and 1. So we have 2 plus 1. That's why we come up with 3. Same as here with the 5. So 3 plus 2 is 5. 5 plus 3, 8. 8 plus 5 is 13. 13 plus 8 is 21. And 21 plus 13 is 34, and so on. So we're getting the series of numbers by just adding up the two numbers before it. Now here, remember, the Fibonacci sequence can be written as a rule as x of n is equal to x of n minus 1 plus x of n minus 2. So this is the rule where x of n is term number n in the Fibonacci sequence. Okay, so we have here an example. In example 9, find the 7th and 8th Fibonacci numbers. So we have here for our solution, for 7th Fibonacci number, we have, using this formula, x of n is equal to x of n minus 1 plus x of n minus 2. We're looking for the 7th Fibonacci number, so we just have to substitute the value of n, substitute it with 7. So we now have x of 7 is equal to x of 7 minus 1 plus x of 7 minus 2. So ang mga n, ginvaluean lahin 7. Okay? Now, simplify 7 minus 1, we have 6. 7 minus 2, we have 5. That's why we come up here with x of 7 is equal to x of 6 plus x of 5. Now, where did we get this 8 plus 5? So, maybe you're confused. Di inti ka nga 8 ngayon 5, kaya ano naging 8 ngayon 5? So, remember, again, that this 6 and 5, they are only the number that tells the sequence kung ikapira iton nga x kung ikapira iton nga Fibonacci number. Okay, so we have here the x of 6. We will go back here to our sequence. Hain an aton dida ika-6 6th number in our Fibonacci sequence. So we have 1, 2, 3, 4, 5, 6. Ya din aton ika-6. This is the 6th number in the series of Fibonacci sequence. So that's why we have here 8. Then the x of 5, the 5th number in our sequence, we have 1, 2, 3, 4, 5. Our 5th number is 5. That's why we come up as well here with 5. Now, simplifying 8 plus 5, we have 13. So, we now have our x of 7 is 13. Another, we have for 8th Fibonacci number. So, we have, again, using this formula, just substitute the value of n. So, since we're looking for the 8th Fibonacci number, we'll substitute substitute it with 8. So we now have x of 8 is equal to x of 8 minus 1 plus x of 8 minus 2. Now, 8 minus 1 is 7, 8 minus 2 is 6. And then, again, look at the number in the series that we have. Hain ang pang-pito, ngan pang-6. The seventh number, we have 1, 2, 3, 4, 5, 6, 7. Our seventh number is 13. That's why we have here 13. And our sixth number is 1, 2, 3, 4, 5, 6. Again, it's 8. So we now have here 8. 13 plus 8 is 21. That's why we come up with our answer, which is x of 8 is equal to 21.
Now let's move on to finding the Fibonacci number using the golden ratio. When we take any two successive Fibonacci numbers, the ratio is very close to the golden ratio. And this is the symbol for the golden ratio, which is approximately, this is its value, 1.618034, and so on and so forth. In fact, the bigger the pair of Fibonacci numbers, the closer the approximation is. So for example, if we have here two numbers, successive Fibonacci numbers, we have 2 and 3, its ratio is 1.5. So this is from 3 divided by 2, or B over A. Okay, this is where we get our answer 1.5. This is its ratio. Another, we have for 3 and 5. So 5 over 3. This is where we get this answer. Okay, another, 5 for 5 and 8. We have 8 divided by 5. Its ratio is 1.6. And so on. Okay. Even more surprising is that we can calculate any Fibonacci number using the golden ratio. So we have here, remember, Fibonacci number using the golden ratio, we have here our formula. This is our formula. We have x of n is equal to golden ratio raised to n minus the quantity of 1 minus the golden ratio to the power of n divided by the square root of 5. Or we can also have x of n is equal to x of n minus 1 times the golden ratio. So how are we going to find the Fibonacci number using this golden ratio? We have here an example. For example number 10, we have find the sixth Fibonacci number. We have here sixth. We're going to look for the sixth Fibonacci number using the formula for the golden ratio. Okay, we have here, we just copied the formula here. And then what we're going to do, if we already have our formula, is to substitute the values of n and the golden ratio. So where are we going to get the value of n? Okay, as you can see here, we are going to look for the sixth Fibonacci number, and n here is the one that is telling us the sequence of the Fibonacci number, okay, the position. So we're going to substitute the value of n with 6. Okay, since we're looking for the sixth Fibonacci number, 6, and then the value of golden ratio. Where are we going to get the value of golden ratio? From here. Okay, from this one, dinhiin natin kakuha ang ating value. That's why we have 1.618034 raised to the power of 6. Again, our value of n is 6. That's why we have here 6. And then copy, minus, and then quantity of 1 minus the value again of our golden ratio. So same la din he, hindi din. And then raised to n. Our n again is 6. Divided by square root of 5. It atin is square root of 5. This is fixed. Okay? Square root of 5 talaga in here. Since that is what is in our formula. So we're just going to copy, and then what we're going to substitute only is the value of the n and mga n nghin and golden ratio. Asya light aton babalyuan. Okay, now let's simplify. How did it come up with this answer? Okay, remember the rule in sequence of operation. Ipagkakasunod-sunodhan operation natin. We have the PEMDAS rule, right? We're following the PEMDAS rule. Again, P is for parentheses, E is for exponent, M for multiplication, division, addition, subtraction. So first, to simplify this one, our numerator, we have to look for parentheses if there is, kung may groupings. And here in our example, we have our groupings here, the one with the parentheses. So asya laanay it aton uunahan simplify. So we have 1 minus 1.618034, and it yung magiging answer. So we'll have here, let's just copy first. 34 raised to 6 minus, again, the answer here will be negative 0.618034 raised to 6 divided by the square root of 5. Okay, again, we get this one from the answer of this 1 minus 1.618034. Okay, the answer negative 0.618034. Okay, we're done with the parentheses. Next, we have to simplify the exponents. So we have 1.618034 raised to 6, or to the power of 6. Its answer will be 17.944273 if we're going to round it off. Okay, and then just copy the minus, and then negative 0.618034 raised to 6. What will be the answer? It will become positive 0.055728. Let's just use 6 digit in the decimals. Okay, again this will become positive. Look at the exponent. It is even number. So if our exponent is an even number, automatically our answer will be positive. Pag odd number hiya, kwaki, magiging negative. Pero pag even number, positivity hiya. And then just copy square root of 5. So we have 17.944273 minus this one will be equal to 17.888545. Again, we round it off. We just use 6 digit from the decimals. And then square root of 5. So if we're going to divide this one, we will come up with an answer of 8.000000. Have 6 zeros, 52. So as you can see, we have almost same answer. So nagkaibala din it's because here in our solution we round it off. We round off numbers. Pero if you're going to use exact amount or exact answer here, kay halaba pa hiya dinhi. If you will use the exact number, you will come up with this. So mas harani liwat hiyahan han answer. The closer the approximation. Okay, and if we're going to round this to the nearest whole number, of course our answer will be 8, just like this one. Okay, another, let's have this. We also have this formula. X of n is equal to x of n minus 1 times the golden ratio. So again, just substitute the value of n and the golden ratio. So we have 6 here. We have 6 minus 1 times the value of the golden ratio. And then, of course, our answer here, 6 minus 1 will be x of 5. X of 5. Ini nga 5 din he. This is not from this one, ha? Diba our answer from x of 6 minus 1 is x of 5. Diri intikang din he nga 5. Diri intikang din he. X of 5, our value for x of 5 is 5. This is from the sequence or the series of Fibonacci numbers that we have from earlier. 1, 2, 3, 4, 5. This one. Okay, ang ikalima na series of numbers, x of 5, we have 5 as its value. Okay, that's why we come up with 5. And then just copy the golden ratio. Then if you're going to multiply this one, you will come up with this answer. So as you can see, you will also come up with 8 if you're going to round it off to the nearest whole number. Okay, now let's move on to the chapter exercises. So here, you just have to figure out what is next in the sequence. So just write the letter of your answer for test 1. And then for test 2, identify the next pattern, the next number in the pattern. So same, you just have to look for the pattern and then identify what should be next here. For test 3, find the nth term of the Fibonacci sequence, round off to whole numbers. So here, you have to use the formula in finding Fibonacci number using the golden ratio, the one that we had earlier. The one on page, that was on page 9. This one. Okay, so just use this formula and do the same as what I have shown you. Okay, and then for test 4, this is where you are confused, I guess. Test 4, you have to find the ratio of 2 consecutive Fibonacci numbers, round off to 7 decimal places. So here in test 4, first thing that you have to do is you have to look for the Fibonacci numbers. Since these are not yet the Fibonacci numbers, so you have to look what is the x of 6. An x of 6 natin. Okay, let's use this one na lang. So, which is our x of 6 here? So, we just have to count. Or you can also use the golden ratio, the formula with the golden ratio, to look for the x of 6. So, tutod yun laanay niyo an x of 6 ngayon x of 7. After that, if you already have the x of 6 and x of 7, so for example, let's have x of 2 and x of 3. Okay, so for example, if we have like this, first you have to look for the x of 2. And an ating x of 2 is 1, 2. We have 1. Our x of 2 is 1. And our x of 3 is 2. Okay, so we have 1 and 2. Next that you need to do is you have to find the ratio of these two numbers. Pag nakuha na niyo an value, hini, you have to find the ratio of these two consecutive numbers by dividing, of course, just like what we have also here. An atan ginbuhat din So for example here, ang duha nga magkasunod nga numbers, we have 2 and 3, and a ratio is 1.5. So gin divide. Ano ang una? Una ang 3 and b. Okay? So 3 divided by 2. So here, in our example, we'll have, to find its ratio, we'll have 2 divided by 1. And 2 divided by 1 is 2. So this is the ratio. Okay? So here, remember, you have to round off to 7 decimal places. So kung halaba na hiya, may mga decimals, just like here. So ganyan So you have to round off to 7 decimal places. 7. Just like here. 1, 2, 3, 4. 2, 4, 6. Oh, this is 9 na pala. So 7 la. Round off to 7 decimal places. Okay? So that's what you're going to do in test 4. And then for test 5, you have to make a reflection paper. Okay? Direction: explore and take photos of different patterns found in objects, plants, and animals are present in your surroundings that can be modeled mathematically. After such, make a reflection paper on the nature of mathematics. You may include your photos in your reflection paper. Will be graded with your reflection paper using the rubrics below.